Hey all, let's talk today about how to control and power multiple LEDs with Arduino. You've probably seen similar LED cube projects like this one. Trying to control LEDs requires a special LED driver chip to handle all the connections and the power properly. For instance, a 3x3 LED cube with 2 color LEDs would require 27 LEDs and 54 control pins. So obviously having some of these special LED driver chips can come in handy. Keep watching and you can find a super expensive way to blink a single LED. Today we'll look at the MAX6971 and the MAX6969 LED driver chips. There's 16 output LED drivers. Essentially you can write 16 bits as 0 off and 1 on from the Arduino, and they'll control the respective LEDs. Okay, so let's jump right in and figure out how to hook this up. So we have the MAX6971 here. It's a 24 pin and has a 16 LED output. So what we're going to do is we're going to power our circuit with a 9-volt battery, but we'll need to get 5 volts to power the MAX6971. So let's look at the basic connections here. Pin 1 will be ground, so you can just go ahead and ground here. And for pin 24 on the other side, we have a plus 5 volts. So how are we going to get 5 volts? Well, a trick we can do here is take our Arduino and we'll take the battery leads from the 9 volts and we'll plug those into the VN, which will then regulate the voltage for us to 5 volts and 3.3 volts. So we'll take the VN and ground connections and hook those up from our battery. And then we can take the 5-volt connection from the Arduino and connect that into pin 24. Now also, when you read the data sheet, there needs to be a capacitor on pin 24 to keep out some of the noise. You can use a 0.01 microfarad capacitor if you have one Maxim chip, but since we're going to chain it later on, I'll just go ahead and put a small little 2.2 microfarad capacitor here. And that'll just kind of also hook onto pin 24. And go to ground. If needed, the LEDs can be powered by a completely separate power source. In our case, we'll just use a single 9-volt battery to power both the Arduino and the LEDs. But we're not powering the LEDs through the Arduino ports, as that would kill the Arduino. Just to reiterate this point here, the Arduino is not powering the LEDs. It's just offering a digital representation of the LED state to the driver. The data wires to this are just 3 wires that we need on pin 2, 3, and 4. And those 3 wires are the DN, clock, and LE. So, and on the Arduino side, it can be pretty much arbitrary. So why don't we just use 2, 3, and 4 on the Arduino side. Okay, and at a 10,000 foot view here, what happens is you set the LE signal to high, and that indicates that you want to change the LED states. And then we shift in the DN byte that represents the state of the LEDs that we want as 0s and 1s. And then we unset the LE, and that indicates to latch the value in. And then the clock, we actually don't need to do anything with the clock itself, but what happens is during the shift out method in the Arduino, it uses the clock and the latch to make sure everything gets locked in on time. The LED driver is a shift register, which uses flip-flops and a loop to maintain the state of the lights until the next byte is shifted in. In other words, once you set the desired LED state, you don't need to keep writing that state until a change is needed. Another benefit of this driver chip is that it's constant current, meaning as you add more LEDs, they will maintain the same brightness. It only needs a single resistor to set the current for all 16 outputs. This means you don't need to couple each LED with its own resistor to maintain current. A couple other things that we have to set would be on pin 23 is important because you set the current to all the outputs with pin 23, and you can calculate this exactly how you want it, but for now we'll just overshoot and use a 1K resistor on pin 23 and just tie the other end to ground. And then the final thing is the OE, which is the logic bypass. In the logic bypass here, we just want to set it to ground so that the chip is enabled. That's pin 21. So take pin 21 to ground. Awesome. And then the rest of these pins are just the outputs for the LEDs. So you have output 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 through 16 here. And what we'll do is we'll set those up with LEDs right now. We'll be using 3-pin LEDs. It's a red and a green. So it has 2 control pins for the colors, and then we'll set the middle one to +9. And the other thing is when you're looking with the LEDs, you want to make sure they're all set with the same orientation. So one of them has a much thicker prong on the right hand side, and one of them looks a little bit more slanted. So we'll go with the thicker prong on the right hand. Now, one problem I have with the multicolored LEDs is that the colors seem to have different brightnesses. Looking at the specs, they even have differing voltages and a differing limiting resistor. So in this example, the green looks super bright and the red is not very bright. Okay, let's go ahead and look at how we can configure 2 of the MAX6971s to control the LED array, but also be able to have a little bit more control on the brightness, the current setting. We'll use 2 chips here, and we'll kind of straddle between the LED between the chip, and control it that way. So what we'll have is a kind of like a red chip, one that controls the red and one that controls the green. So luckily it's pretty easy to set up the configuration. We can kind of mirror the setup that we have before. So this is pin 1, and pin 1 goes to ground. And then we need to come up with 5 volts. So I've got 5 volts here, but we'll need to share this. So I'm going to move it over a little bit. Okay, and we'll put 5 volts there. And then we'll just need to come from here and power up our second chip here. So we can pop it right there. Now we need the chip enable logic. So that's going to be grounded on pin 21. We need our current limiting resistor. I'm going to use the same right now, and we'll check it later here, different values. That's a 1K. And then we just need 3 more pins from the Arduino. So we pick 2, 3, and 4 for the first one, and I'll pick 10, 11, and 12. And pin 10 is brown, so that goes to 2, 3, and 4. Like that. That's pretty much it to power up the chip. And our LEDs will just straddle these. Now, technically, these are controlling pin. If I straddle between here and here, the first chip is going to be pins outputs 1 through 8, and the second chip is going to be outputs 8 through 16. We're just going to put all ones and all zeros, so it won't matter in our demo here. But you might want to route these a little differently. Okay, and here we have an alternating red and green LED sequence controlled by two MAX6971s. So the top one is controlling the red and the bottom one is controlling the green light. It's not much difference visually, but we'll see the code is much different. One thing you can do is if we wanted to tone down the green, we could just add another resistor. Now the green is much more subdued, and that'll allow you to kind of even out the colors a little bit more. And here's an example of the same LED driver chip hooked up to a 2x2 LED matrix, outputting random values for the LED state. Alright, and we'll go through the code real quick. The code for the LED driver is not super complicated, so it should be a pretty simple thing here. Like I said, the pins that you use on the Arduino are arbitrary. So here we're picking 2, 3, and 4. This is the single chip setup. Then you can just define the LED state. This is essentially doing it in binary, but you can define it in hex or whatever you want. This is basically a pattern that alternates off and on every other light for all the outputs, 1 through 16. And then you have a setup mode. All you have to do is set those pins as an output. And finally, we have the loop function. The first thing to do to coordinate the data right is to set the latch pin high. And then we use this shift out function, and we use that to put the data into the actual chip. You have to coordinate it with the clock, and this is handled automatically. So we give it the clock pin and the data. And since this is a 16-bit chip, we actually have to do it in 2 bytes. So we send it the high and then the low byte. And finally, we set the latch pin back down, and that should write the data out. We're going to delay so that we're not writing out the chip every time we can. And then just to make it interesting, I invert the LED state. Also, like I said, if you don't need to change the LED state, then you probably don't need to write this out in the loop. You would only want to do this if you're changing the LED state. Otherwise, they'll remain constant. All right, and now we'll go over the coding scenario where we have the 2 chips, and one is for like the red color and one is for the green color. So we first define our data pins 2, 3, and 4. So for the second set of pins, I just named it with a 2 at the end and put 10, 11, and 12. Basically in setup, we just define them all as outputs. But in the loop, now we actually have to explicitly set both chips and their states each time we go through the loop. Okay, and how this would work is so the first time through the loop, I have to explicitly set my red chip high, so I turn the red on, but on the green chip, I have to turn the light off. Okay, but now if I want this to blink, the next time around, what I need to do is on the red chip, set it to 0, and on the green chip, set it to high. So now it's going to alternate between red and green, red and green, red and green in this loop. And that's all we have today on the LED driver chips with the MAX6969 and 6971. Thanks for watching. Please like and subscribe. Thank you.